This is the inductor we have seen. What you have observed, when rate of change of current, that is di by dt, is passed through the coil, because of that there is some flux developed. Yes or no? Flux is developed. As flux is developed, the rate of change of flux, because of the rate of change of flux, there will be an EMF. EMF is produced across the coil. This is the thing you have observed. Yes or no? That means rate of change of current, rate of, that means di by dt is there. Di by dt is nothing but what? It changes with respect to time. The graph you can observe, it is changes with respect to time. As the t increases, as the t increases, automatically the current also changing. See here, it is 0 increasing, and the graph here it is maximum, and again it is coming to 0, like that. That means because of change in current, change in flux takes place. As change in flux results in EMF, that is observed across the inductor. Now if I apply DC, if I apply DC, what happens if I apply DC? Tell me, what happens if I apply DC? Here already we know that derivative of d by dt of constant, d by dt of constant is what? D by dt of constant is what? Tell me. Derivative of any constant term is
0.
0. So what is constant here? DC. DC, what is
0.
it? This is AC waveform. This waveform is AC waveform. If I see the waveform for DC, this is DC waveform, no? Constant magnitude. Constant magnitude. Suppose 20 is there. It is maintaining 20. But here in the AC it is changing, no? So derivative of 20, what it will give? Derivative of 20, that means derivative of current is constant, no? It is 0. So clearly we can say that here di by dt is 0. If di by dt is 0, what is v? We know v is equal to l di by dt. L di by dt is the formula actually we have. So this di by dt term becomes to 0. As di by dt becomes 0, what is the voltage? 0 into anything is 0 into
Zero.
anything is
Zero.
0.
Zero.
So voltage is 0. That means as voltage is 0, is there any voltage? Is there any EMF? There is no EMF, no? EMF is 0. If EMF is 0, it is just like a normal conductor only, no? This inductor will behave like a normal conductor. It is not a inductor. Okay. So for inductor, if change in current passes, there will be an EMF. But suppose if I apply DC, it is automatically behave like a conductor only, just like normal copper wire only. It is not a inductor. It does not have any storage. It is not a storage element. Is it clear, all of you? This is all about inductor. Now we will start with the capacitor now. Okay, we will start with capacitor. See, this is the capacitor. We'll take drawing. Okay, so capacitor, what is meant by capacitor? Capacitor is also a storage element. It stores the energy. It stores the energy in the form of magnetic, sorry, in the form of electric field. Inductor stores the energy in the form of magnetic field, no? Because of current passes, there will be set up of magnetic field. But whereas the capacitor stores the energy in the form of electrostatic field, okay, in the form of charges. So what actually capacitor is? Let us see that. Here capacitor consisting of two conducting plates. Okay, capacitor consisting of two conducting plates. This is the two conducting plates now. Okay, two conducting plates. Initially these two okay, these are the two conducting plates. In between these capacitors, what is placed? In this between capacitor, there is some dielectric medium. What is meant by dielectric? Dielectric is nothing but insulating medium. Insulating is insulation. Insulation means which does not allow, which there is no passage of current. Okay, so electrically, initially, whatever the capacitor is there, this capacitor is electrically neutral. Okay, so like this. Okay, two plates I have taken. What about Yuvraj? What happened? Why you're drawing? Okay, this is electrically neutral. This is, suppose if it is positive like this and negative like this. These are two conducting plates I have taken, positive and negative. Two plates I have taken here. Okay, two conducting plates. Electrically neutral means same values is there, means it is no charge. Okay, so now what I am doing is, here when I applied to a, suppose when I apply to a storage element, or suppose if I apply some voltage source here. Okay, if I apply some voltage source here, that is positive, and here it is negative. Okay, positive I have taken, negative I have taken here. What happens? This negative, whatever the electrons are there, electrons will attract towards positive, yes or no? Negative charge always attracts towards the positive terminal of the battery. So one by one, these electrons will attract towards positive terminal of the battery. One by one it will attract towards here. And here these electrons are there, no? These electrons, whatever the electrons are there, these electrons will attract towards the positive. Here negative plate is there, no? These electrons, whatever the electrons are there, will attract towards the positive terminal of the battery. Slowly what happens is, here all these electrons, whatever the electrons are there, here excess in, I will show you with the diagram like this. Initially it is electrically neutral, no? So what happens? In the above plate, all electrons are nullifying. That means all these electrons are attracted towards the positive terminal of the battery, and here in all these electrons will attract towards the positive plate of the capacitor. So finally what you will have, you can observe all the, that means in the above portion all negatives are disappeared, no? It will become like a positive plate. Okay, capacitor one side it will become positive plate, whereas here, because huge number of these holes will be created here, what happens? Huge number, excess number of electrons are created. That means two positive, one is a negative plate, another one is positive plate. So it will, you will get that just like a potential difference. Plus is there, minus is there. What is meant by plus and minus? There is existing some potential difference. Okay, voltage is developed across the capacitor. Okay, some voltage. How much voltage will be developed? Whatever the supply voltage is given here, whatever the supply, suppose if V is there, automatically the same amount of voltage will be developed across the capacitor. Is it clear, all of you? The same amount of, up to that extent, and we cannot increase the beyond that one. If you increase, what happens? So if you increase that capacitor voltage more than that of the supply voltage, the dielectric strength, whatever the dielectric material is there, will break up. Okay, will going to get into damage. Okay, so we have to take that the capacity, that means the same rated value, that is up to, suppose if it is 220 range, we have to take in terms of farad. Okay, capacitor units are farads. Okay, this is the units for capacitor. Here this capacitor store, that means capacitor is what it is going, here it is just like a battery, no? So what happens now? This is behaving like one plate is positive and another plate is negative. Okay, one plate is positive, another plate will be acting like a negative. Now what I am doing is, after that, just like a battery in your mobile battery is there, no? So like this, one plate will become like a positive and one plate will negative. Now whatever the battery is there, now I am utilizing this battery in order to lighten up the bulb. Now I am connecting one bulb here. Okay, I am connecting one bulb here. This is the bulb I am connecting here. Okay, this is bulb I have taken here with switch. With the switch I have taken. Now what I am doing, I want to lighten up this bulb. What I will do, I have to close the switch. No, now I am closing this switch. If I close this switch, you can observe that there will be a closed path. Okay, there will be a closed path is there. Initially bulb is not glowing. Now what happens? because of that closed path, and some battery, here battery already stored with some voltage, no, whatever the stored energy is there, the stored energy will try to discharge. Okay, why it is trying to discharge? Because some element is connected in to that capacitor, that means to the battery. Okay, it will try to discharge, that means whatever, always these negative electrons are there, no, these negative electrons will attract towards the positive terminal of the battery. This negative electrons is there, no, it will flow in this direction and it will come back. Okay, one by one these electrons will be going and will attract. What happens if it will disappear, no, one by one plus will be disappear, this will be disappear, this will be disappear. Likewise this negative will attract towards positive. What happens? Disappears. Okay, and negative, all these will be disappearing. So what happens? After something, this bulb will not glow. That means just like your mobile phone, initially you have charged to 100 percentage and you are utilizing that battery, you are utilizing the mobile phone. After some time your your phone will be showing that 0 percentage. That means the stored energy is becoming zero. What you are going to do? Again you need to give the supply to the battery. Okay, likewise we have to recharge, or we can call it as we have to again charge the battery. So that is the purpose of battery. Is it clear, all of you? So capacitor, what is the purpose of capacitor? Capacitor is nothing but a battery only. So capacitor consisting of two plates. Okay, that means how are the two plates? One plate is what? One plate is positive, another plate is negative. Two plates are there, one is positive, another one is negative. Okay, is it clear? So capacitor can be represented by two parallel lines or one parallel line, one with C shape. Okay, this is the capacitor symbol, circuit symbol is there, and the units are farads. Farad is a huge unit, so we can write the units. That means capacitor range will be less, so you can write millifarad, microfarad, picofarad, like that. Those are the units. F, it is indicated with F. Okay, I think everybody, it is clear about capacitor. Capacitor is a storage element. Okay, this capacitor will be depending upon the property of capacitance. That is, C is equal to C is the capacitance. How much capacity? Capacitance is nothing but storage. Okay, it stores the energy. How it will store? It will depend upon the area of cross section. That means area and distance between the plates. If distance is more, what happens? If distance is more, the capacity will be decreases. Is my voice is getting all of you? Please, anyone respond?
Yes, sir.
Sir.
Okay, okay.
Yes, sir.
Who is striking that? Okay, if distance is more, capacitance will be increases. If distance between two plates is less, the whatever the stored energy will be more. Okay, that is the thing you have to observe. That means capacitor stores the energy in the form in which supply it is storing, DC or AC. Plus and minus I am indicating, no. Okay, it is storing the energy in DC form. Okay, so that's why you can observe that there is no storage elements AC, because if you take AC, what happens? Positive. If I take AC, what happens? Positive energy is stored and again negative energy stored. Sometimes positive and negative will be cancelled up. That's why there are no storage elements like AC. That's why we are making use of the power generations. Suppose if you have requirement, what you are doing? We are making use of the power plants only, no? Like thermal plants like that. Okay, so we cannot store the energy, bulk amount of energy cannot be stored. So that's why there are no batteries. Only batteries will store the energy in the form of DC. Okay, whatever the energy in your house, also we are using inverters. Okay, inverters is nothing but batteries only. So actually we are getting the AC supply. So that AC supply we are making into DC by conversion, by making use of diodes. After conversion of that, again we are storing. After that we are changing into DC. That DC is stored in the form of batteries. Okay, you can observe that your mobile charger, have you seen your mobile charger, all of you? Have you seen your mobile chargers?
Yes, sir.
Is it
Yes, sir.
just like a normal? Okay, is it just like a normal
No,
plug, TV plug, or the it is in bulk mode?
TV.
Normal TV plug size or bulk mode, the charger plug point.
Normal TV.
The charger is there now, the cable. It is bulk or not?
Yes, sir.
Yes, sir.
Why it is bulk? Because why it is bulk? Because for the battery, okay, for the battery we need only DC. Okay, we need only a DC. DC supply is required because it stores the energy in the form of DC. So what we are doing is in the mobile charger you are having that plug no, that will stores the, okay, that charger one is there no, that will stores. I will show you the charger. Video is clear now? So this is the charger. Size is more now. So in this charger, in this charger, in this charger, there is a rectifier circuit will be there. Okay. What happened? 530, rule number 530. Yuvraj. Sometimes you are making lines, sometimes you are standing and roaming. Can't you sit and listen? Okay, so this is the battery, charger. In this charger what this one is the plug. Here there will be some diode circuit will be there inside of that one. That means it will, whatever the AC is there, that AC will convert into DC by making use of this charger. Okay, so after that, whatever the 5 volts of voltage is there, that 5 volts will be applied to the mobile battery. That only small in millivolts, milliamps. You can observe that 7000 mAh, 7000 mAh, 5000 mAh, 5000 mAh, 5000 into m. M value is what? 10 power of minus 3, 5 ampere like that. Okay, 2000 mAh like that will be there. That means current rating. Is it clear? So this is the mobile charging. That is why you are having the capacitor stores the energy in the form of DC, not AC form. Is it clear all of you? Capacitor, the capacitance is depending upon how much stored energy it will depend. It will depend upon the area of cross section and distance between the plates. Okay, as area is increases, automatically capacitor also directly related. And this epsilon value, what is meant by epsilon? Epsilon is nothing but permittivity. Here it is epsilon is equal to epsilon naught into epsilon r. Okay, that is the two things will be there. One is absolute permeability and relative permeability. Here this is due to air and this is due to the dielectric medium. Okay, it depends upon the dielectric constant. It will depend. As it more means the capacitors dielectric constant is more means the capacitance is also more. Is it clear all of you? The capacitor purpose.
Yes, sir.
Okay, now we will see that how the capacitor stores actually. The capacitor stores the energy in the form of what? In the form of charges only, no? That is positive charge, negative charge. Okay, so that is the thing. So capacitor stores, capacitor C is equal to charge per voltage based upon the supply voltage only, no? So based upon the supply voltage only, here the charges are moving. Charge per voltage, the capacity stored energy we can say. Okay, simply we can write Q is equal to what? Q is equal to that is charge is equal to, how that charge depends? It depends
CV.
upon C into V. You just remember by making use of CV Raman. Scientist name is there, no? So Q is equal to CV Raman. That formula you can remember. Okay, likewise by remembering his scientist name, Q is equal to CV. So C is equal to charge per voltage, where Q is equal to C into V. So this is the thing we got. So is there any capacitor? In that capacitor, is there any current? This is a dielectric medium, no? Is there any current between this one? Will current flows? Will current flow through the dielectric insulating material? There is no current flowing. Whatever
No
the charges
current.
is there, okay, no current through this dielectric. The charge will accumulate across the plates. That is positive plate and negative plate. Charge will be accumulating over the plates. Okay, there is no passage of current. So here that's why if you want to know the current, if you want to know, current is nothing but a flow of charges only. But in terms of charges only we are taking. Previously For inductor and resistor, we have taken current, but here the thing is we need to more focus on charge only. Okay, that is Q is equal to CV. This is the thing very important. So based upon that means flow of charges, based upon analysis purpose, I am considering that flow of charges is nothing but current. So by making use of that one, this is charge. Flow of charges is nothing but with respect to time only, no. So just to take derivative of that one, d by dt of q. Derivative of charge is nothing but what? Rate of flow of charges is nothing but current only, no. That is I. I is equal to dq by dt. What is q here? What is q? Q is product of capacitor and
CV.
voltage. Okay. Q
Capacitor
is
and
equal to,
voltage.
okay, Q is equal to C into V. Just substitute. So here capacitor, the capacitor area, direct, whatever the area is there, capacitor C is equal to epsilon A by D, no? It is constant only, no? We cannot increase the area while it is the charging. Can you increase the area while it is charging or dip? Okay, area is fixed, no? Assembled part, we cannot change. Distance also we cannot change. So that is constant. I am taking that capacitor outside. Okay, and voltage we can change by increasing or decreasing the voltage levels. Okay, dv by dt. That's why C is outside. So here I got the current I. I got the current I. I need to find the voltage now. Okay, I got current I. For previous values also we have written V is equal to what? For resistor, V is equal to I into R for resistor. For inductor, V is equal to L into di by dt. Minus will be there, that is Lenz's law effect, but we can write directly V is equal to L into di by dt. Now I want to write the voltage for capacitor. Okay, how we will write voltage for capacitor? So we need to write with the by making use of this formula, that is I got current as I is equal to C into dV by dt. I is equal to C into dV by dt. By making use of that, we will see. Okay, so here I am writing dV by dt outside here. dV by, okay, I will clear, otherwise next slide I can go now. See here, dV by dt is equal to what you got? 1 by C into I. Okay, but I am interested to find voltage only, no? How we will get voltage? I want to find voltage only. So in order to get voltage, what you have to do? You are having the differential term. In order to eliminate that differential term, we need to integrate on both sides, so that the differential will going to get cancelled here. Okay, I am integrating on both sides. So if I integrate integral of dv by dt with respect into dt and 1 by c, integral C is constant, no, I am writing constant outside, that is capacitor 1 by c integral I into dt. So here dt, this dt get cancelled, and integral of 1 into dv. Integral of 1 into dv is what? Integral. If for differentiation 1 dx means constant means 0, but integration the value will be repeats. That means whatever the variable is there, that variable we need to write. That is v we need to write. That is 1 dv is v. Integral of 1 dv is v is equal to 1 by c integral I dt. This is the voltage term we got. Okay. For inductor what you got? For inductor what you got, ma? V is equal to L into di by dt. But whereas for capacitor, here I am writing here for ohms, for resistor it is product of current and resistor I got, and for inductor L into di by dt differential term I got. Now for capacitor I am getting in terms of integration. Okay, here normal multiplication, here differential multiplication, now integral multiplication I am getting here. That is 1 by c integral I into dt. Okay, so all are I is product only, now this is I, current is I, general current, instantaneous value, here it is differential value, here the current is integral value. That is the thing we got, three different values we got. And what about, these are the voltages we got. What about current? V is equal to IR. I is equal to what, ma? I is equal to, tell me, I is equal to
V by R.
V by R. For inductor IV, how much you got? I is equal to, here you got as in differentiation, no? You got as in differentiation, where you will get as integration, no? Differentiation you got means integral term 1 by L integral V dt. This is the thing you got in the last class. Now here integration term we got, for voltage we got integration. Yes or no? For voltage we got integration. For current what you will get? Current what you got? I is equal to C into dV by dt. This is the thing only we got, no? C into dV by dt. So these are very important. For 2 marks they will ask what is VI relationship. Okay, very important this question. Okay, we have to write all these values, general directly voltages and currents you need to write. Is it clear all of you up to here?
Yes, sir.
Okay, now we will see power and energy. What is power? What is power? Product of voltage and current only, no? Okay, product of voltage and current. If you have power, then only we can deliver the voltages. Yes or no? So if you have power, we can deliver the voltages, whatever the voltage is there. It's okay. P is equal to VI. What do you got? I. What do you got? I in the capacitor. I is C dV by dt. So we will have
V by
power
R.
as, okay, not V by R. For capacitor I we got as C dV by dt, not V by R. That is for resistor. We are writing power for capacitor. Okay, C dV by dt I we got. So that is VC or CV. CV it is convenient. So I am writing C is CV Raman like that. If it is easy to remember, so that's why I am writing CV into dV by dt. Both are same only. Okay, and it is kilowatts, not watt. Okay, kilowatts or watts. Okay, what about energy? Energy, tell me. Energy is nothing but power into time only, no? Energy is equal to power into integral power into time. Time is derivative term. What is power you got? What is the power you got, ma? CV
dV by dt.
by dt, CV dV by dt, and already dt is there, no? This dt I can have to write again, no? That is dt, and integral is there, no? Is there any cancellation? This dt and denominator dt will get cancel up. Okay, and c is constant, no? C is constant. I can write C outside. C integral V into dV. Now you tell me for integral V dV. For integral dV V dV. V
V
square
square
by
by 2. V
V
square by
square
2.
by,
2.
okay, V square by 2. Or simply I can write energy stored in capacitor is half CV
Half
square.
CV square. CV
For
square.
okay. For half CV square. For energy stored in inductor, what you got? Half
Half Li square.
half Li square. Half Li square. Nice. So this is all about capacitor. I think everybody it is clear what is resistor, what is inductor, what is capacitor. Resistor means what? Resistor is a just normal wire. For any wire it is consisting of some resistance. So it, what about that resistor? What it will do? If resistance is more, it does not, that means current will be less. If resistance is less, current will be more. That means resistor is nothing but which opposes the flow of current. If resistance is more means opposes the flow of current. Whereas in inductor what happens? The rate of change of current passes through it, rate of change of flux linkages is produced. That rate of change of flux linkages will induce an EMF according to Faraday's laws of
EMF.
electromagnetic, according to Faraday's laws of electromagnetic induction. Okay, so that is the thing we got. Okay, whereas for capacitors what you have observed, capacitor is a It is a two conducting plates are there. One plate is positive, another plate is negative. They are separated by dielectric medium. So initially they are electrically neutral. So what happens is when I apply some voltage source or a battery to the capacitor, it will stores the energy up to the supply voltage. Up to the supply voltage, it will going to stores the energy. That means whatever the voltage is there, that voltage. After that, after storing of that voltage we can utilize by connecting any loads like bulb load or any other load. Okay, if I connect that loads, when it is a closed path is there, that means this whatever the stored energy is there, that stored energy will discharge through that whatever the load is there will discharge through the load. So finally at some time the total energy will be discharged. Okay, and again what you have to do, again we need to charge the battery. That means charge the battery is nothing but charging the capacitor, so that again we can utilize. Okay, generally these batteries or capacitors are utilized in used in inverters, UPS is also there, no? Computers, for computers we are using UPS, uninterrupted power supply. Whatever the AC is there will connect it to the UPS. That UPS consisting of batteries, that batteries will stores the energy in the form of DC, and again conversion circuit will be there, it will convert, and it will whatever the system work will be there we will utilize for some time. Okay, up that means when up to that battery discharge level. So that is the purpose of battery, and we will continue another series and parallel circuits in next class, because time is only 2 minutes is left. Okay, in next class we will continue, that is how what happens if the capacitors are connected in series, and what happens if the capacitors are connected in parallel. And you can also we have discussed that the capacitor stores the energy in the form of DC. Okay, stores the energy in DC, not AC. If we take AC, what happens, whatever the stored energy will be there will be cancelled, because positive there, negative there, positive negative will cancel. That's why we are not storing. So that's why if batteries are there, no need of the generation of plants also, no? That means always at the time of our utilization only we are we are using the power plants. Yes or no? What, Sumit? Tell me. Sumit, is there any doubt? Okay, anybody is having doubts till now?